Part 17, Model Aircraft Missions with Aviator. We'll begin by creating a new scenario using the default time period. In the Welcome to STK window, click Create a Scenario. Let's give the scenario a unique name, such as STK Aviator. I'm going to leave the default start and stop time. Simply click OK. It's up to you if you want to close the timeline view. I'm going to, in order for you to be able to see more of my screen. Before I proceed, I'm going to save my scenario by going up to the toolbar in STK and clicking on the Save icon. If needed, you can click STK User and then make sure you select the STK Aviator scenario. If your window opened with STK Aviator already showing in the Save In window, that's okay. Just click Save. We're going to use a local file for our analytical terrain. Therefore, I'm going to turn off Terrain Server. In the object browser, right-click on STK Aviator and select Properties. Browse to the Basic Terrain page, and in the Terrain Server field, disable Use Terrain Server for Analysis, and then click OK. Bring the 3D graphic window to the front, and in the toolbar of the 3D graphic window, the next to last icon is called Globe Manager. Click that icon. Globe Manager will open up in the lower left-hand side of STK underneath your object browser. In the toolbar for Globe Manager, the first available icon is called Add Terrain Imagery. Click that icon. When the Open Terrain and Imagery Data window appears, in the upper right-hand corner of the GUI, you will see a three-dotted ellipsis button. Click that button. Expand your Browse For folder, select the Computer, C drive, Program Files, AGI, STK11, Help, STK Training, and Imagery. Click OK, and you should see a list of terrain and imagery files. Select the Point Mugu China Lake PDTT terrain file type and click Open. When the Use Terrain for Analysis window pops up, click Yes. By clicking Yes, we've loaded this terrain file both analytically and visually. In Globe Manager, right-click on Point Mugu and select Zoom to. You can use your left mouse button to lay your terrain flat, and if you zoom in, you will see the mountains and the terrain in the area. On top of that terrain, we're seeing Bing maps. Let's save our scenario. Next, we will load the ARINC 424 runways using the Aviator Catalog Manager. In the menu area, open Utilities and select Aviator Catalog Manager. When Aviator Catalog Manager opens, on the left, expand Runway. Select ARINC 424 runways. Where it says Use Master Data File on the right, go all the way over to the right and click the ellipsis button. Select Computer, C Drive, Program Files, AGI, STK11, Help, STK Training, Samples. Look for a file called FAA NFD18. Select that file and click Open. In the Aviator Catalog Manager window, select Save. On the left, you will see all the airfields that have now been loaded that we can use in Aviator. Simply close the GUI by going up to the upper right-hand corner and clicking the Close button. Save. Next, we will insert a ship object which will be used as a waypoint in our scenario for our aircraft. Return to the Insert STK Objects tool. Select Ship as your object. Insert Default as the method. And click Insert. In the Object Browser, right-click on the ship and select Properties. In the Altitude Reference field, change the reference type to MSL, or Mean Sea Level. On the right-hand side, click the Insert Point button, and that will insert a waypoint. Click on the latitude cell and we'll enter 33.5 degrees. You can just enter 33.5 and hit your enter key and it will fill out the rest of that cell. Click in the longitude cell and type in -120 and then hit enter. We do not want our ship to move. It's going to be a static ship. So just above that waypoint, you'll see where it says Route Calculation Method, and currently it states Smooth Rate. If you open that pull-down menu, you can select Specify Time, and now go back over to the right, click Insert Point, and the only thing we're going to do is we're going to change the time for the second point by adding 3 hours. So I'm going to change it from 1801 to 2101 and hit my enter key. Then we can click OK. And if I zoom out a bit in my 3D graphic window, I can see my ship object. Now we're going to model an aircraft with the Aviator propagator. We're going to insert an aircraft using From Standard Object Database method. So return to the Insert STK Objects tool. Select Aircraft as your object, From Standard Object Database as your method, and click Insert. In the name field, I'm going to type in the word Hornet, H-O-R-N-E-T. And then I'm going down to the bottom of this field and click the search button. You're going to see two selections for the Hornet. I'm going to select the FA-18C Hornet and then click Insert. You can close the Search Standard Object Data window, and in the Object Browser, you can now see your Hornet. Right-click on the FA-18C Hornet and select Properties. On the basic route page at the top, where you see Propagator, the Propagator is currently selected to Aviator. In the mission window, right-click on Phase 1 and select Insert First Procedure for Phase. In the Site Properties window, on the left, where it says Select Site Type, select Runway from Catalog. At the top, where you see Filter, simply type in the word Mugu, M-U-G-U, and hit your Enter key. You will see two selections. Select the Point Mugu NAS Naval Base VEN 0321, or your first selection. Go down to the bottom right-hand side of the GUI and click Next. In the Select Procedure Type window, select Takeoff. Where you see Runway Altitude Offset, change that value to 7 feet. Underneath that, enable Use Terrain for Runway Altitude. The runway altitude offset will lift your aircraft an extra 7 feet off the runway. Depending on the size of the aircraft and the model that's depicting the aircraft, you might have to lower this value or increase this value to make sure that the complete aircraft is above the terrain. Go down to the lower right-hand corner and click Finish. You will see your procedure as your takeoff roll and as you begin to climb out. At the bottom of the screen, in the GUI, click Apply. You will get a flight path warning telling you that Aviator works best when the scenario is defaulted and references mean sea level. So in this GUI, there's a button that says Set Globe Reference to MSL. Click that button. And then click OK. Now you'll never see that pop-up screen again. Right-click on the takeoff procedure. Select Insert Procedure After. On the left of the Site Properties window, underneath Select Site Type, we are going to select STK Object Waypoint. Let's name this waypoint Ship. And in the Link To window, select Ship. On the right, you will see an offset mode. Open up that pull-down menu and select Bearing Range Relative to North. Change the range to 10 nautical miles and click Next. In the Select Procedure Type window, select En route where you see altitude, disable Use Aircraft Default Cruise Altitude and change the MSL altitude to 15,000 feet. In the Navigation Options field, change the nav mode to Arrive on Course and change the Arrival on Course field to 180 degrees. Click Finish and then click Apply. Save your scenario. Right-click on the En route procedure and select Insert Procedure After. In the Select Site Type field, click on End of Previous Procedure and then click Next. In the Select Procedure Type window, select Basic Maneuver. Rename the name field and we'll call it Straight to NM for nautical miles. Ensure the strategy is currently selected to straight ahead. In the basic stop conditions, turn on downrange and change the downrange value to 2 nautical miles and click Finish. Apply. Right-click on Straight 2 nautical miles and select Insert Procedure After. In Select Site Type, enable End of Previous Procedure and click Next. In the Select Procedure Type window, select Basic Maneuver. And we're going to call the name of this maneuver Weave, W-E-A-V-E. Change the strategy to Weave. In the basic stop conditions, enable downrange and change the downrange value to 1 nautical mile and click Finish. Apply. Right-click on Weave and select Insert Procedure After. Select End of Previous Procedure and click Next. In the Select Procedure Type field, select Basic Maneuver and give the name of the maneuver, we will call it Loop. Change your strategy to Loop. In the Load Factor field, change the value of the bottom of the loop to 5 G sea level and click Finish. And if needed, click Finish a second time. Apply your change and save your scenario. Right-click on Loop and select Insert Procedure After. In Select Site Type, select End of Previous Procedure and click Next. In Select Procedure Type, select Basic Maneuver and rename that maneuver Left Turn. Set the strategy to Simple Turn and click Finish. And click Apply. We're going to reuse two of our procedures. So return to your mission window, select both Weave and Loop. Right-click and select Copy, Paste Edit, and then select Copy Procedures. Right-click on Left Turn and select Insert Procedure After. In the Select Site Type, select Super Procedure and then click Next. Click on the button that says Load Procedures from Clipboard and you will see your two procedures. Click Finish. And now you've repeated those two procedures on the way home. Click Apply. Now we will return to base and we will land. So return to the mission window, right-click on the super procedure and select Insert Procedure After. In the Select Site Type window, click on Runway from Catalog, and in the filter field, type in Mugu, M-U-G-U, and hit your Enter key. Select the first Point Mugu selection and click Next. In the Select Procedure Type field, select Landing, change the approach mode to Intercept Glide Slope. This will give us a smoother landing. It will come in slow and land on the airfield. Go down to Runway Altitude Offset, change the runway altitude offset to 7 feet, and enable Use Terrain for Runway Altitude, and click Finish. Apply. Next, we will check our fuel state. If you return to the mission window, right-click on Landing and select Profile Data at Final State. If you scroll down a bit, look for the fuel consumed and note the value, and then close the window. We will enable dynamic wind from the NOAA ad service. In the toolbar area, you will see an icon for Mission Wind Model. Click that icon. Change the model type to NOAA ad service. click the Manage Data button, and in the upper right-hand corner, select Add Current Forecast. At times you might get an error message. Let's just click OK. If we don't get the data, if it doesn't work in our scenario, we can always load constant airspeed or constant crosswinds. So click OK. And in the atmosphere field, turn on non-standard surface conditions. And change the sea level temperature to degrees Fahrenheit and change the value to 90 degrees. Click OK. And click Apply. Right-click on the Mission Profile window and select Profile Options Properties. Turn on the secondary y-axis and select Course Crosswind, and then click OK. And you can see the course crosswind as it fluctuates depending on where your aircraft is flying and the heading your aircraft is taking. Click Apply. Return to the mission window and right-click on Landing and select Profile Data at Final State. Again, find your fuel consumed and note any changes based on the winds and the temperature. Then you can close the window. Click OK and save your properties. Click the red reset button in the animation toolbar. In the object browser, right-click on the FA-18C Hornet and zoom to. It's best to use X real-time when you're looking at an aircraft using Aviator. So I'm going up to the animation toolbar, turn on X real-time animation mode, and maybe increase my X real-time multiplier to a value of 4, which you can see in the lower right-hand corner of STK. Click the Start button in the animation toolbar, and you'll be able to see your aircraft as it takes off. You'll notice that when the aircraft takes off, depending on what day it is and what your crosswinds are like, if you look at the nose of the aircraft, at times you will see that it's not exactly aligned with its velocity vector. This is the effect of the crosswinds on your aircraft, and this is called a crab angle. I will end the movie here, but if you continue to watch your scenario, you'll be able to see your aircraft as it flies out and performs its basic maneuvers, both the basic weave and the loop.